Welcome to the DESI Astro. In this tutorial on Astropy, our objective is to learn that how to stack astronomical feeds images from a data cube using a Python. So, stacking feeds image is a technique used in astronomy to improve the quality of your astronomical images by combining multiple exposure and multiple band images of the same object to provide higher quality images to your scientific studies. Alright, so the process of stacking images generally happens in two steps. So first step is the alignment of the images, and then you can apply your either taking average or sum or median of your pixel intensity value to make a single image from the multiple images. Alright, so stacking can help in a different ways. So first you can improve your signal to noise ratio in the image, and then you can also study about the hint object by enhancing their features, and you can also like correct some artifacts like cosmic ray and sensor noise etc. Alright, so this tutorial is the continuation of my earlier tutorial in which I have uh, teach you about how to stack astronomical feature spectra from a data cube. So I will highly recommend you to go and watch this tutorial because I'm going to take some coding stuff from my previous tutorial. So for that I have attached the link in the description, and you can also watch this tutorial by clicking on the top right corner of this video at this time. Let's do it using Python coding. So for doing that I will import some libraries, right? So import a library, right? So you can see I have this much of library I have used. So I will just copy this code and I will put here, right? After that I will read my data cube, right? So data cube, so I will go to my previous tutorial and here I have my data cube, right? So I will just go here, and so here is my cube. Okay, so now my image is in the Flux SDU. Okay, so which is also a image SDU. So for that I have to extract the Flux, right? So I will go, and here I have extracted the Flux, right? So I have extracted my Flux. So here is my Flux data, right? And you can see your Flux data shape having this much. Okay, so you have this is y and this is x, so you have a 74 into 74 spectral, okay, a spectral image, right? Now I will upload a single image, right? Okay, so plot single image. So for type here plt dot figure, and then so for that type here command plt dot im show, and give here a flux and truncate the cube along your z-axis. So I want to, okay, so I have z-axis 6732. okay, so I have to extract, say I want to extract my image at 1000, and then all aspects, all right. Then type plt dot so here you can see that here is my galaxy image, right? So in this way you will have a total of, okay, so you will have a total of 6732 images, okay, and you have to stack all images, okay, along the z axis. So let's stack it. So stack all 6732 images into a single file, right? So for that, give here a variable name called a stack image equal to np dot or take your mean, okay. So first take mean, right, and then you can give your say a flux variable, right. So flux variable reason behind giving this axis 0 is because we have this shape, okay. So we have to combine all images along the z along the wavelength axis. So this is what I mean by 0, okay. So this is why there is 0. So now you got your stacked images. Now you can plot it, okay. So this is mean a stacked image, okay. You can stack also by median if you want, right. So I will give only the mean for time being and I will plot it, okay. So plot this image, okay. Okay, so for that type here plt dot im show, right, and give here a stacked image, and so here you can see that here is your image and this is your image, okay, like at a single, and you can also like plot color bar to visualize. So type here plt dot color bar. So here you can see that it goes up to 1.75, and if you plot color bar, so plt dot color bar, so here you can see you are going up to 2.0 and above. So this is what I mean by stacking, right? So because your intensity value of your each pixel will get increased and your image will look much finer with the great details. So this is what I mean by stacking. So now let's stack this image by median, okay. So just type here median and run it. See, there's not much change, but it can change, okay. You can also like now you can give the weight, okay, weight to your each image at a single spectral axis. So this is a simple step to stack images using a mean method, right. So I'll just mean, and you can also make it sum, okay. So just take it sum np dot sum and then run it. See, this time your pixel value has increased up to 14k. So this is the sum of your all pixel value, right, but this will not work properly, so I will just take the mean, right, and things will appear like this. So this is a simple procedure I have followed, and I hope this tutorial is very clear to you that how to stack astronomical images from different exposure or different band in the wavelength, and how to stack by either a mean, median, or by just taking the sum of your each pixel. So thank you and stay tuned for the next videos.